Now, let's proceed with a new chapter, Basic Laws. In the previous chapter, we have studied or understood certain basic concepts like current, voltage, power, energy, etc. of present in a circuit. Okay, power, voltage, current, etc. present in a circuit. To actually determine the values of these variables of current, voltage, power, and energy, we need to understand or study certain fundamental laws of electric circuits. These are the foundation or base laws which actually govern the functioning of electrical circuits, and these laws form fundamentals of electrical circuit analysis. When I mean by something electrical circuit analysis, it is nothing but it is a process or a scientific technique which involves the finding of unknown variables such as current, voltage, power or energy in a given electric circuit. So that is what electrical circuit analysis means. So these laws are nothing but Ohm's law and Kirchhoff's laws. Kirchhoff has given two laws, Kirchhoff's first law and second law. So totally three laws. So these are the fundamental laws of electrical circuits, and now the design and analysis of electrical circuit also depends upon these laws. So in addition to these fundamental laws, we are going to study some of the techniques also in this chapter. So these fundamental techniques become very handy in our process of circuit design and analysis. And these techniques involve something called as series and parallel resistor connections, and the transformation of connections delta to Y and Y to delta transformation. And the application of these laws and techniques will be restricted to only resistive circuits at this point of time. However, we will finally apply these laws and techniques in solving real life problems of electrical lighting and design of DC meters. Okay, let's start with our concepts. So it is well known that any material, say conducting material, because we are talking about electrical conductivity and all these things, electrical engineering. So every material has this property to oppose the flow of electrons, and that is generally known as resistance. Okay, it is usually represented by the symbol R. Okay, the resistance of any material, okay, of any conductor, say, of a uniform cross-section area A, depends upon its length, and we can represent it in mathematical form as R is equal to rho L by A, where rho is nothing but electrical resistivity, or you can call it simply resistivity, and where L is the length of that specimen and area is the cross-section area as denoted or as given in this figure over here. So good conductors are like copper, aluminium. They have low resistivities. Their resistivities are very low, but whereas materials called as insulators such as mica and certain semiconductors, they have the resistivity value very high. So they oppose the flow of current, and because the resistance will be high due to high resistivity. So circuit element used to model this current resisting behavior of a conductor or any engineering material is a resistor, which is denoted by this symbol in a zigzag line. So for the purpose of constructing circuits, resistors are usually made up of metallic alloys and carbon compounds. Okay. Yeah. And this is the circuit symbol of resistor. Okay. And there is a German physicist called Simon Ohm, George Simon Ohm. German scientist called as George Simon Ohm, who actually given a relationship between voltage and current and resistance in a circuit. So this is the person, George Simon Ohm, who has given relationship between voltage, current and resistance in a circuit. And that relationship was actually known as, or called, or widely popular as Ohm's Law. So this relationship between voltage, current and resistance is what known as Ohm's Law. Because it is given by him, the law is placed under his name. So Ohm's Law states that, okay, Ohm's Law states that voltage V cross a resistor is directly proportional to the current flowing through the resistor. So this is the Ohm's Law statement. So voltage V is directly proportional to the current flowing through the resistor. So that is, when you write it down mathematically, voltage is directly proportional to current. And Ohm defined a constant of proportionality, or a proportionality constant called R. So when it is included in the mathematical equation, it becomes like this, where this constant of proportionality is what known as our resistance. And this resistance is given by this relation, rho L by A, resistivity into length by area. So resistance is a material property which can change if internal or external conditions of the element are altered, that is, length or cross-section area is altered. And not only that, resistance depends upon temperature as well. So the temperature dependency of resistor is known as temperature coefficient of resistance, basically. Okay. And the unit of resistance is the name of the scientist itself, Ohm, and the symbol is given is like this. So that is regarding the resistance. So from this equation I can write R is equal to V by I. So I can define a resistance of 1 ohm. So resistance of 1 ohm is said to be existing in a circuit if a current of 1 ampere, okay, if a voltage of 1 volt is able to circulate a current of 1 ampere, then you said there is a resistance of 1 ohm. So this is how you define a resistance, ohm. Okay.